Dear students, in this video we are going to see 6.1. Here, first we will see what is Cauchy's residue theorem. What is Cauchy's residue theorem? Let C be a simple closed positively oriented path and suppose F is analytic inside and on C except at finitely many isolated singularities Z1, Zx, etc., Zn inside the given simple closed curve C. Then how to calculate this integration? Integral over C f of z dz is equal to nothing but 2 pi I multiply summation of all the residues of the function at the isolated singular points. Now here we will see how to write the pole and how to find the residue values. Suppose we have a simple pole. We can say simple pole at x z equal to a, or we can say that a singular point. Then how to find the residue? That is residue of the function at a. This is the rule. Limit z tends to a, z minus a, f of z. Suppose we have a pole of order m at z equal to a for the function f of z. Then how to find the residue? That is residue of the function at a is equal to limit z tends to a 1 over m minus 1 factorial d power m minus 1 divided by d z power m minus 1 z minus a whole power m f of z. Okay. Now here what is m? M is nothing but order of the singular point or pole. Okay. Now we can see a few examples on this, how to find the residue on the poles. Now you see the function f of z is equal to 2z over z minus 1 z minus 2. This is a given function which has simple poles at z equal to 1 and z equal to 2. We can say simple poles, or we can say this is singular point, this is also singular point. Okay. Now see, we have to find the residue. How to find the residue? Residue at z equal to 1. Okay, that is limit z tends to 1 z minus 1 f of z. Why we write here z minus 1? Because we are going to find the residue at z equal to 1. That's why here we write z minus, what is this, pole, then multiply f of z. Then you substitute the limit z equal to 1. That's why the value is minus 2. What is f of z? F of z is this. So you substitute this value here. So z minus 1 is cancelled. After that 2z over z minus 2. So you substitute 1 here. So you will get minus 2. Similarly here, residue at z equal to 2. What is that? Limit z tends to 1. Z minus 2 f of z is equal to 4. Z minus 2 multiply f of z. You substitute this value here and then you cancel z minus 2. Then substitute z equal to 1. You will get this value. So that is called residue at z equal to 2 for the function f of z. Okay. Similarly, you see here, what is f of z? F of z is equal to, this is a second example, 2z over z minus 1 whole square z plus 4. Now you see, we have a double pole at z equal to 1. Why we say double pole? Because you see here, z minus 1, here the degree is 2. That's why we are telling z equal to 1 is a double pole, or we can say multiple order pole. Okay. Now simple pole is nothing but here the degree is 1. So z equal to minus 4 is a simple pole or singular point, we can say. So now what is the rule to find the residue value at z equal to minus 4? You see, limit z tends to minus 4, because minus 4 is a simple pole. So you write that z plus 4, z minus 4. So z plus 4, multiply the function, then you simplify z plus 4, then you substitute z equal to minus 4 here. Okay, so that you will get this value. Similarly, here you find the residue at a double pole at z equal to 1. Okay, so how to find the residue of pole order m? You see here, this is the rule. Okay, so now here what is the order? Order is 2 in this question. That is double pole. Okay, order is 2. That's why we are writing limit z tends to 1 by 1 factorial. Just you substitute here in this rule. M is 2. So 2 minus 1 factorial. D power 2 minus 1 is 1. So d divided by d z minus a whole power 2 f of z. Now you see You substitute the rule. So what you will get here, z minus 1 whole square multiply f of z. So here if you substitute f of z, so z minus 1 whole square, z minus 1 whole square get cancelled. So the remaining value is 2z over z plus 4. So that is 2 times limit z tends to 1. Then you substitute z equal to 1. Here you will get the value 8 divided by 25. That's it. These two examples are for how to find the residue of the simple pole and pole of order more than 1. Now you see the first question. Here we find this integration value by using the Cauchy's residue theorem. Okay, how? Here you will see. Now what is the value of c? Means what is given? That is c is equal to modulus of z is equal to 3. It's nothing but a circle of radius 3 and center 0. Okay, that is given. On this c, we have to find the integration value of this by using Cauchy's residue theorem. What is Cauchy's residue theorem? You see here, that's what first we discussed. To find the integration over c of the analytic function, integration with respect to dz is equal to 2 pi I multiply sum of the all residues at the isolated singular points at poles. Okay, so what we are going to find? We are going to find the residue at each pole. Then you are going to take the summation, then multiply by 2 pi I. Okay, you see the first question. Now here you see, first we write the given function, like see in the denominator, what is z minus 2i? That is z minus 2i. Okay, here what is z cube minus z? We can write as a factor. Okay, as a linear factor. Now you take z as a common factor. So here z is the value outside. Then z squared minus 1. That is z minus 1, z plus 1. Okay. Now here you see z equal to 0, z equal to 1, z equal to minus 1, z equal to 2i. All four are simple poles. Why we say simple pole or singular point? Means isolated singular point, because here what is the degree? 1. So that we are telling simple poles, okay, or isolated singular points. Okay, so now what we are going to do next? We are going to find the residue value at each pole, okay, by using this rule. We know this rule, rule 1. We are going to find the residue at each simple pole. It's very simple. Limit z tends to a, z minus a, f of z. That is the rule. A is the pole or singular point. Now you see here, first one is z1, that's point. Z1 is equal to 0. That is the singular point. So now, what is the residue at residue of f at 0? So now what you do? Just you write the function, then multiply this z minus 0. Actually here z minus 0. So that is cancelled. Z minus 0 and z minus 0 cancelled. That is z and z cancelled. So that you are getting this value. Put the limit z equal to 0. So that you are getting this. That is minus I over 2. Now, similarly, you find the residue of the function at 1. Okay. So now, what here we are doing at 1 means z minus 1. Here z minus 1 already is there in the function. So it should be cancelled. Then the remaining value is this. Okay. So now, after that, you simplify, then substitute the limit z equal to 1. Then you will get this value. Similarly, you can find the residue of the function at minus 1. Residue of the function at 2i. Okay. So that finally, here, you take the summation, see summation of all the residues at each pole, then multiply 2 pi I. So what is the final answer? 6 pi I. This is what Cauchy's residue theorem to find the integration of this over C. Here one important point is, you see here, what is the circle? Mod z equal to 3, which means this circle, see here, for example, you draw the circle. Actually, we have to check each pole, either simple pole or pole of order more than 1. See, is that equal to 0? Here 1, here minus 1, here 2i, all are inside the circle, inside C. That's why here we are finding the summation of all the residues of each pole, then multiply. Understand what I'm telling? Now, see the second question. See, we have to find this integration over C. What is C? Mod z equal to 2. Now you see here, what is the pole? Here, this is the pole or singular point we can say. Z equal to I. is a pole of order 3 because here degree is 3. That's why you apply the rule number 2, this rule, to find the residue. Okay, how to find the residue? You put here for m 3. So 2 times derivative, here 1 by 3 minus 1, 2 factorial. Here z minus a whole power 3 multiply f of z. Okay, that is here. Okay, so that z minus I whole power 3, z minus I whole power 3, both will be cancelled. Then you substitute the limit z equal to 1. See here, very important. Here 2 times you make the derivative of this after the cancellation. Okay, so what is the first time derivative? 2z. What is the second time? 2 will come. So that 2 factor will be cancelled. So the answer is 1. So that's why we are getting 1. Okay, so now here we have only one pole, means triple pole of order 3. So that here we have only one residue. So what we are doing to find the integration value by the Cauchy's residue theorem, what we do, 2 pi I multiply sum of the residues. But here we have only one residue. So that here just you multiply. See, 2 pi I here multiply this one again is equal to same answer. Again is equal to 2 pi I. Okay, that is your answer. Okay, now you see here the another question, integral over C z dz divided by z minus 1 whole square z minus I. Here what is given? Mod z equal to 2. So first what we have to do, we have to check what are the poles and order. You see here z equal to 1 is a pole of order 2 and z equal to I is a simple pole. Okay, so what we do here, now next you have to check, before finding the residue we have to check that these poles inside the circle. Yes, z equal to 1 definitely inside this circle and z equal to I is also inside the circle. Therefore we can find the residues of each pole. Okay, so now see, pole of order 2, because double pole, we are writing double pole means here you see the pole of order 2, which means m is equal to 1 in the rule. You substitute here m is equal to 1. That's why here this and this will be cancelled. After that you one time make derivative. You see here d by dz of z by z minus I. You make the derivative of z by z minus I one time, then substitute the value z equal to 1. That's it. That is 1 by 2. Okay, now similarly here this is simple pole. So how to find the residue? That is limit z tends to I, this value, then you cancel z minus I, substitute z equal to I, you will get this value. Final answer is minus 1 over 2. So now how to find this? How to find this integration? Now by Cauchy's residue theorem, what we do? See, 2 pi I multiply what we do? You add 1 by 2 and this minus 1. 1 by 2 minus 1 by 2 into 1 by 2 minus 1 by 2 is 0. So 0 multiplied 2 pi I is 0. Actually here 2 pi I will come. Actually here 2 pi I multiply the sum of the residues. Here first residue, this second residue. So you add both, it will be 0. So final answer is 0. This is the integration value. Now what is this question? Again, find this integral value over this C. What is C? Z minus 1. Modulus Z minus 1 is equal to 1. Which means here center is 1, 0. That's here center. And radius is 1 unit. From this point you make 1 unit radius, then make circle. Then what you do? Now you see here, see, Z cube minus 1 is given. So you make factors. You see here Z minus 1, Z square plus Z plus 1 equal to 0. So that what are the poles? I can say at z equal to 1 and this is a pole. Understand? So now for next what you do, you check these poles inside or outside. See here, z equal to 1 definitely inside. Okay, z equal to 1 is inside the C. Okay, now what is z equal to? Exponential of means plus or minus 2 pi I by over 3, which means z equal to C minus 0.5 plus 0.9 I1 pole. This is another pole, but all the poles of order 3, there is no doubt, because degree 2, all the poles of degree, see, all the poles of order 2, that is sure. Now you see here, this is the only one pole inside C. These two poles, see here, this one and this one is outside C. So you cannot find the residue. No need to find the residue. So now at z equal to 1, you find the residue. We know that this is simple pole. Sorry, this is a double pole, means order 2. So put m is equal to 2, substitute, then you will find the value of the residue. Then what you do? You multiply this with 2 pi I, so that you will get minus 4 pi I over 9. That's it. This is your answer. Thank you.